Hello class, this is a video tutorial on exponential functions and motion. Certain motions tend towards a certain displacement. These occur in displacement functions that have an asymptote and occurs as t approaches infinity. So let's do an example where this is involved. The motion of an object's height above ground, x, at t seconds, is modeled as x equals 2 minus e to the power of negative 3t. Calculate the initial displacement, velocity, and acceleration. Initial means we are looking for the values when t is equal to 0. To find that, we need our displacement function, 2 minus e negative 3t. We find its derivative. The derivative of e is negative, it's itself times the derivative of its power. That's negative times negative 3 gives us positive 3. And its acceleration is differentiating once again. We get e to the power of negative 3t, it's itself, times the derivative of t, of this power here. So it's going to be negative 9. The value of its displacement when t equals 0, that's x equals 2 minus e negative 3 times 0. Well, that's e to the power of 0, which is 1. This is 2 take away 1. Its initial displacement is 1. The initial velocity, we do the same thing. Take the velocity, 3 times e to the negative 3 times 0. This is going to be 1. So 3 times 1 is 3 meters per second. Let's write meters for this. Again, assuming that this is in meters and in seconds. Take note of the units of measurement in questions you're doing, but it's okay to assume that it's usually these. And lastly, for its acceleration, once again, this is going to be 1. Negative 9 times 1 is negative 9 meters per second squared. Determine the eventual displacement, velocity, and acceleration of the object. When it says the eventual, that means we're going to let t equal infinity, or we can substitute larger and larger values of t and c where these values tend towards. For this, you can do this in a table of values, or you can graph it. For this, I'm going to let t equal, let's begin on 0, 10, and 100. And let's see what happens here. Our displacement, velocity, and acceleration. Here we go. Let's test first our displacement. 2 minus e to the power of negative 3 times 0. We already have that, that's 1. 3 times 10. Oh, it's already at 2. Let's test again, times 100. Again, it's already at 2 again. That's very, very fast of it. Let's check again for velocity. 3 times e to the power of negative 3 times 0. It's at 3 times 10. Oh, okay, so this is already, that decimal place there is really far down, so the velocity is actually getting towards 0. Let's test it again, times 100, 0. Testing this for acceleration, negative 9 e to the power of negative 3 times 0, negative 9 times 10. I think this is also tending towards 0. So determine the eventual displacement, velocity, and acceleration of the object. So we can say as t approaches infinity, x approaches 2, the velocity approaches 0, and acceleration approaches 0 as well. Sketch each of the functions and describe the motion. Okay, for this we're going to need 3 different graphs. Here is my displacement. Here's my velocity. And I know I need more space in the negative region for velocity. Oh, sorry, for acceleration, my mistake, because it begins at negative 9. Okay, so in that case, there we go. And lastly, acceleration. Let's duplicate this one more time. For displacement, we saw that its initial value was 1 meter. Okay, so let's say that this here is 1. Yep, that's 1. Let's say that this is 2 meters, so this is displacement. That's time. So we saw that as time approaches infinity, so as we move along here, the displacement should approach 2. So it should look something like this. There we go. For the velocity, we saw that its initial velocity is at 3 meters. So let's let this be 3. We saw that as time went on, it approached 0. So there should be an asymptote, like so. Obviously, you can get a more accurate graph if you use more values, more table of values. And lastly, for the acceleration, we begin at negative 9 meters per second squared. So let the acceleration time. Let's let this be 9. And it's approaching 0 as time goes on. So as time goes on, acceleration should be approaching 0 like this with an asymptote like so. So this is at negative 9. Describe the motion. So we can say what we actually found here. We saw that as time progresses, the object approaches 0 velocity, which is a stationary point, approaches 0 velocity with a displacement of 2 meters above the ground. Because remember, this is an object's height above the ground. So, hope I gave you an insight into exponential functions and motion. Hope to see you in the next video. Best of luck.